Moving along to the next part of the standard, taking a root. And we're not talking about roots of a tree. We're talking about like square root and cube root. Remember squaring, cubing, or taking something to a fourth power? Remember that little number that's next to another number, and it tells you to multiply that number by itself that many times? Well, if we write that out, see, squaring a number would be that number by itself 2 times, so we would have x times x. 3 times we'd have x times x times x. 4 times we'd have x times x times x. You get the idea. So, well, what we want to do if we want to undo these operations. If I had taken something to a power, but then I forgot what the original number was, and I wanted to get it back again. That's what roots are all about. If I take the square root, I use a little symbol like this. And what I'm asking is, what number was multiplied by itself that came up with this number that's now under the radical sign? It's also called a radical sign or a root sign. And this is called taking the root. We use this symbol. It looks like a long division symbol, but it's got this extra little tick here at the end. Can we zoom in on that, please? Get in real close. Use that 200 zoom built into the camera. Oh yeah, there it is, right there. See that little tick? So this is not the same as long division. This is taking a root. Okay, we can move back out. The symbol here is called a root sign, or sometimes called a radical sign. Okay, I've covered all this. Remember, it's not long division, it's taking a root. We have here, say, the square root of 16, or here we sometimes put a number next to the root sign. I'll tell you what that means in a second on the next slide. We have to learn the lingo, so I'll cover it for you. We want to talk like a college kid here. Here's the real names for the parts of the radical expression. This number, small one, right above the little hook, is known as the index. That's exactly like the opposite of the power that we used to get this number inside. The number inside has a very special technical name. It's called the radicand. The radicand. Almost everything in mathematics has its own special name, and this is the name for this. Radicand is that thing that's underneath the radical sign. And the sign itself is called the root. So there we have it. Memorize these if you possibly can. Please do. The radicand is the one that's under the radical sign. The root is the name for the sign itself. And the number that we're taking the root of is known as the index. Moving along. The index is the most important. That tells us exactly what operation we need to perform. For example, in the problem here, this third root of 27. We're asking, the index tells us what power needs to be reversed. What power was used to get to 27? The third power was used. How do we get the number that was multiplied by itself 3 times? Let me draw it out a little more and make it more clear. Nah, I just did it already. What number, when multiplied by itself 3 times, would give you 27? The answer? 3. I'll prove it to you. 3 times 3 is 9. So then 9 times 3 is 27. Therefore, the cube root of 27 is 3. You see, it's 3 times 3 times 3. It's 3 times itself 3 times. That would result in 27, and therefore the cube root of 27 is 3. If there is no index, that is to say, if it looks like this, where you just have the root sign but no number here, it is understood that the index is 2, because that's the one we normally use. And this is called the square root of a number as well. For example, this one could be read as the square root of 81. And what it is asking is, what number times itself twice equals 81? The answer? 9. Because 9 times 9 equals 81. The square root of 81 is 9. Because 9 is the second power, or 9 times 9 is 81. You'll normally find a square root sign on most scientific calculators as well. Even on some very low-powered calculators, you'll find a square root bar. Knowing the second and the third powers and roots of the first 6 positive numbers at least is very helpful. Roots and radicals come up all the time in mathematics, especially Algebra 2, and later on even in calculus. You're never going to get away from these guys. I highly recommend that you sit down and memorize the first 6 numbers and their squares and their cubes so that you can find them in future problems. Here they are. If we have x, and then we have a column for x squared and a column for x cubed, we can lay out what these first 6 numbers will come to. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, etc. If you want to construct your own table like this, you can just use a calculator at first, but don't stick to the calculator the whole time. Lay out the table, then make yourself some flashcards and memorize these by rote. You should have them down, just like you have your multiplication tables down. And if you don't have your multiplication tables down, get on that too. Pause and practice here. At this point in the lecture, you should pause the tape and do some exercises. I can wait.